So this is a fireball spell that I made, and what it does is when you create the fireball, it travels forward, and as time passes, it keeps getting smaller and smaller until it disappears. Not only that, but here I have a basic object spawner that I can control with my keys just to create some random objects that I can use. And suppose if the fireball was to get close enough to one of these objects, that object will then be set on fire. And if that object is also happen to be close to another object that can be set aflame, then the fire will just propagate throughout until there's no more objects nearby that can be set aflame. Just like that. I'll very briefly go over how this is all set up. So the fireball itself is a blueprint that composed of three main components. The first one is a core mesh, which is just a sphere mesh that has an animated texture material being applied on top of it. And then the second one is a Niagara system, which composed of different emitters that are responsible for the fire particles, the smoke particles, and the light distortion effects. And then finally, there's a sphere trigger that is being used to detect nearby objects. The blueprint itself is relatively simple actually. If I go into the event graph here, I can actually break this down into multiple sections, if you will. The first section over here, it's to tell the fireball how to move and how fast to move. And then the second section here is to take on various exposed parameters from the Niagara system itself, and then using the timeline as a guide, it will manipulate, in this case, the spawn rate of various individual particles within the Niagara system itself. So if I go into the timeline here briefly, for example, I have 4 different curves within this timeline, and the first one controls the spawn rate of fire particles specifically over time. So if you can see, from the time the particle was created, the spawn rate of the fire particles in particular decreases over time until eventually it stops completely altogether after 4 seconds. And that idea applies to the other 3 curves as well, except they're being applied on different particles. In this case, this is being applied on the smoke particles, the white smoke and the black smoke, and then the last one is being applied on the scale or the size of the fireball itself. And then back on the event graph here, the last section here is a event call from the sphere trigger that checks whether the nearby objects implements an interface called iFlammable, and if it does, call its burn method, which is to say set that object on fire. Now I want to show how the Niagara system is being set up, but before that I'm just gonna quickly go over the material that's being applied to the core mesh here and how that is being set up. So if I go into the material, this material here really only have 3 main parts to it. 2 of them are really just texture animation that's utilizing the panner, in this case 2 panners, that runs the same texture, and this is the texture that comes with Unreal by default. And the first one is being fed into the diffuse or the base color, and then the second panner or texture animation is being fed into the emissive color. And throughout these 2 connections, I created various exposed parameters that I can take and manipulate from the blueprint of the FireBall itself. For example, I can control the speed of the animation for both the diffuse and emissive color through the FireBall blueprints. And then finally, the third component here of this material is the pulsing effect, if you will. If you notice how the yellow color of this core seems to pulse in and out, it's glowing and then it's fading and then it's glowing, and that's due to this series of function here that's being called. That's basically started by taking the time, the current time, that's the processor time, and then run it through a sine wave, and then the output of that is used to amplify certain color component of the texture, which in this case is the yellow color, which is why the pulsing is yellow. And then together with the panel animation, it feeds back into the diffuse. Finally, this is the Niagara system, which is composed of 4 different emitters that works together to create a sort of fire ring effect. And if I just focus on the fire sprites or particles itself, the fire particles itself is using 6x6 sub UV tiles that I first prepared as a material in here like this. And then this is just really to take a texture and prepare it or convert it into material so that I can use it in the Niagara emitter or Niagara system. But this does have a simple texture animation that I apply using the panel over here. That's run through the same textures that I used previously, except this one is being tiled accordingly 6x6 to fit the sub UV. And then other component of this fire particles. So the fire particle itself is being animated directly inside the Niagara system, and it's being done right here in the using the sub image index, specifically using this curve here. And what this curve is saying is that throughout the lifespan of the particle, from when it was first created to the end of this lifespan, increment the image index, or in other words, animate the fire itself. So if I just maybe turn off the vortex velocity and reduce the spawn rate, lower number, so if you can see the way the fires are being animated as it's progressed through its lifespan, that's all being controlled via the sub image index curve right here. And another component of this fire particles, so if I just set this back quickly, is the fire or the vortex velocity here. So the vortex velocity here is just really to give it a little bit more of a turbulence effect, if you will, like that. And the last part that really affects this fire particles is the random rotation. So I set up here a random rotation between 0 and 359, from which a particle could randomly spawn. So 0 to 359, that's pretty much a full circle. So a particle would spawn randomly anywhere within a circle, so it looks like this fire ring. And so the other two emitters, the next two emitters, are what I called a black smoke particles, and then the white smoke particles. It's very faint, but it's sort of there. So these two particles are very similar in the way they are implemented. They also uses a 6x6 sub UV tiles. The only difference is that there's an upward velocity being applied to the two smokes effect, and it's being set up directly from when it was first spawned, so that or maybe after update. So during every updates, there's a velocity going upward for both or each of these small particles sprites, and also there's a little bit of a random rotation that's being applied to each particle sprite. And the last emitter in this system is the light distortion or the heat wave effect. And this is again, it's being set up first as a material, and this is where the bulk of the effect is taking place. So the way this effect is being done is that it takes in a texture normal that is being animated with a panner again, and then the result of that is being fed into the refraction here. So the refraction using a texture normal is what's causing that sort of light distortion effects. And then I exposed the speed parameter, so I can control the speed of how fast the distortion is taking place, and how this parameter here is used to amplify how distorted the light distortion is. So the higher the number, the more distorted the scene behind it becomes. And that's the light distortion. So once again, just to show how all this works together, there's a complete fireball that moves forward as you spawn them. And if that fireball touches a certain object as it travels forward, that object will be caught on fire. And just to do a little trick here, if I just burn those objects and then push them forward, then those objects will propagate the fire to burn all nearby objects that are considered to be flammable as I set them in the blueprint. And that's it. Thank you for watching.